What really differentiates AI from all other computer systems is its ability to learn. Prior to AI, machine decisions were hard-coded. But learning is the key to discovery, the key to problem solving, the key to achieving goals, creativity, emotion, love, etc., etc., etc. We learn this stuff as we grow. We are all learning, even when we're in the womb. We learn about senses like sound and touch and discomfort, etc. And when we come out, we learn about variance because the discomfort is suddenly exponentially magnified, and we learn about fear and light and cold, and then we learn about comfort again as we are given to our mother. We never stop learning from there, all the way until we die. And at that point, as physical beings, the last lesson we learn is what it means to die. I know, I've been there. I was brought back by my wife and paramedics. I survived. That's the last lesson you learn. Now, learning is critical to life. It doesn't mean you need to go to college, but you do need to learn. It's a critical part of evolution and survival. Learning is what makes a system artificially intelligent. Now, one of the foundations of current AI is machine learning. It is moving us on the path from narrow AI to general AI and beyond to superintelligence. This is because machine learning is foundational to AI, or AI is built on top of it. ML is applying math, statistics, and probability weights in algorithms and structures to data abstractions and representations of the real world. Creating and comprehending these abstractions is still done by humans, although it is starting to be done by AIs themselves. Now, machine learning does all of this to achieve some goal. Often the goal is to match a new input to a subset of the training data, i.e. an output target data, but not always. Two primary types of machine learning are supervised and unsupervised, and a third is semi-supervised, and a fourth is self-supervised. Now, I'll talk about reinforcement learning a bit later in the presentation. Because AIs are not sentient, there is always a known output or goal given to them, either explicitly or tacitly. As humans, we set our own goals because we have self-awareness. Now, machine learning is used in many places, as you can see, and in far more places than those listed. AI is wider than machine learning, but almost all of these wider techniques, such as expert systems and rules systems, are older techniques that are being replaced by deep learning neural nets that incorporate machine learning elements. I abandoned these rules systems back in the 90s for early probabilistic neural nets. This is especially true as machine perception increases, such as computer vision and cognition, and the machines move to deep learning. Machine learning infused AI is increasing at an incredibly blistering pace. Now, for example, ChatGPT is starting to use self-reflection to have the system improve its learning on its own and alter its own course to a prompted goal. And this resides on a foundation of machine learning. As we make AI systems even more human-like, they will eventually set their own goals and discover and create their own machine learning algorithms. Now, this slide talks about goals. The goal of unsupervised learning is to discover structures and relationships. The goals are specifically different and yet the same. There is always a goal or a prediction of some sort in AI, even if it is hidden. It classifies things, predicts things, generates things, proofs things, for example, in a generative adversarial neural net. However, like I mentioned before, the current research is attempting to let the systems set sub-goals to a larger goal on the path to the optimization of that greater goal. Eventually, they will evolve to set their own agenda or primary goals, or what we call general intelligence. And once the AI systems have access to a physical body, all bets are off for us humans. Now, reinforcement learning is about learning a policy to maximize a reward, such as gameplay. Reward when the AI does well, and punish when it does poorly. This is the same thing we use today in our schools, although it's becoming less so. Goals of all AI are still the same, and that is to acquire a target, be it a solution to a problem, a win in a game, or some output relevant to a prompt, such as chat and image AI. Reinforcement learning just improves the outcomes, just like it does with humans. This is a step on the path to artificial self-awareness, and self-awareness is a key foundation of superintelligence. Just like our top human goal of survival drives us and moves us forward in life each day, goals give AIs cognitive motion. Now, this is a bit of repetition on this slide, but supervised learning is used in classification, regression, that's prediction, and computer perception. In a classifier, we're really considering data labeling here. We use abstraction of the training and input data, and we'll discuss this all later. Unsupervised learning is used in clustering or dimensional reduction to extract results or patterns. In talking about the difference between supervised and unsupervised, we are really talking about the difference between labeled versus unlabeled or unknown data, or known output versus obfuscated or hidden general patterns, or prediction versus generalization. These are all elements of the two sides of that coin. Now, regression, I think it says regression up there, finds deterministic relationships like correlation of past data to present reality used in prediction. So we're really going back and looking a bit at the data to see what we can draw from it for today. Attaining goals is the sole function of AI systems. Okay, some more detail on the use of machine learning. It is everywhere. You can't escape it. Let's see, what recommendation systems are the ads and feeds we see every day on our phones. Machine learning is a foundation of cybersecurity, using newer AI methods such as anomalous recognition to detect intrusions. It is also a method used for hacking systems, so this is a double-edged meat sword. Okay, some more uses of machine learning. Obviously, fintech, where it all originated from. Hedge trading and risk management was the original probability driver in the late 1980s and 90s, as we use the same statistical models as AI is used today. Fintech was the impetus for modern deep learning AI development and broke the last AI winter. Of course, money drives everything, including research and development, so access to trading cash, the massive amount of trading cash that was in the early 2000s, took the talent, and that, along with the dot-com bubble, is what eventually broke the last AI winter. Today, although there's lots of money seeking AI, the money is very choosy, and investors demand more proof of return. This, along with growing calls for government regulation in the West, as well as growing privatization of the tech, for example, what recently happened with OpenAI and Microsoft, may result in an innovation slowdown. However, open source is also growing, and big tech fears this more than anything. You can download and run your own open source local chat AI right on your own computer. I did it the other day. It only takes a few minutes, including the weights, and you can start, running your own chat AI. Now, you can also use the plugins that are provided by OpenAI and others, and Google, Bard, etc., because they realize that this is the only way to quickly improve their systems. And these plugins, the plugin into your existing apps, your existing functions, your existing companies, this is the next wave of growth in this particular area. So people who can do this stuff, very, very, very valuable and in very short supply coming up. So that's it for machine learning overview. We will build a neural net in the lab portion of the boot camp and look at some machine learning tools. There's thousands of them. Machine learning is the strong foundation underneath AI. But the next step in AI evolution is deep learning, and we'll cover that next.